Hi everyone, I'm Dr. Kiran Raavi, working as an assistant professor in the Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad, India. So today we are going to discuss Mosfet, MetalOxide Semiconductor Field Effect Transistor. So let us see today's overview of today's presentation. Today we start with introduction. So what is the necessity of importance of MOSFET and what is the basic construction and operation? What are the different types of MOSFET we have, and then characteristics of MOSFET, and conclude with summary. So let us have introduction. So it is a family of FET. MOSFET also family of FET. So it has also again three terminals: gate, drain, and source, and has two PN junctions. So it is again a voltage control device. FET is a unipolar device depending solely on either electron or hole. So if it is hole, so if the operation is depending upon the holes, then we can say the FET is called P channel FET. So the charges present in the FET establish an electric field which controls the conduction path of the output circuit without the need for direct contact between controlling and controlled quantities. So here controlling means here VGS is the controlling parameters and control parameter is output drain current. So the coming to the MOSFET is abbreviated for MetalOxide Semiconductor Field Effect Transistor, and there are two types again. So can be divided into enhancement mode MOSFET and depletion mode MOSFET. Again, enhancement mode is divided into two parts, that is subclassified into N channel and P channel E MOSFET, and depletion mode MOSFET, it is again divided subclassified into N channel and P channel depletion mode MOSFET. So MOSFETs have characteristics similar to JFETs and additional characteristics that make them very useful, and also it is also called as insulated gate FET, IC FET, as gate is insulated from the channel. So what is the basic principle of MOSFET? So here, by applying a transverse electric field across an insulator deposited on the semiconductor material, then the thickness and hence the resistance of the channel can be controlled. So if the resistance changes, means current also changes. So we have to apply transverse electric field across an insulator. So here insulator is SiO2 layer that acts as a insulator. So deposited on the semiconducting material, then the thickness and hence the resistance of the channel can be controlled by applying this transverse electric field. So what are the different types of MOSFETs we have? So these are the control field depletion mode MOSFET means the basic operation, the control field reduces the majority of charge carriers. And enhancement means, so that means in depletion mode you can expect channel. And enhancement mode, so the application of an electric field increases the charge carriers. So this is another definition of this enhancement and depletion mode MOSFETs. So this we have already seen. So the symbols for transistors. So first let us start with the N channel depletion mode MOSFET. So this is the setup for N channel depletion mode MOSFET. So in this, for N channel, we have to consider one substrate, P type substrate we have to take first. So it has characteristics similar to those JFET between cutoff and saturation at IDSS. So here what is IDSS? So it is a drain to source current when gate is shorted, or you can say saturated drain current, and also has the added feature of characteristics that extend into the region of opposite polarity for VGS. So that it can be understood when we discuss the characteristics of MOSFET. So what is the basic construction here? So here we have a gate terminal and source terminal, drain terminal, and substrate, fourth one. So and this represents the channel. So first we have to take the n-doped regions are connected via N channel. So like this here. So that forms source and drain. This N channel is connected to the gate via insulating layer SiO2. So this is the SiO2 layer. So there is no direct electrical connection between the gate terminal and the channel of a MOSFET. So if you observe from the figure, you can say there is no direct electrical connection between gate. So this is gate and this channel. So there is no direct contact. So in between you can observe SiO2 layer that can be act as a insulating layer. The n-doped material lies on p-doped substrate. So this is p-doped substrate and this is n-type n-doped material. Lies on p-doped substrate that may have an additional dermal connection called substrate. So this is additional substrate, fourth terminal you can say. So that's all about construction. So let us see what we have discussed today. So we have started with introduction and we have discussed what is MOSFET, basics of MOSFET and its types. The types of the MOSFETs, we have E-type enhancement mode MOSFET and depletion mode MOSFET, and we have discussed what is enhancement and what is depletion mode MOSFET, and we have discussed N-channel depletion mode and then N-channel enhancement mode we'll discuss. And then in the next session we will discuss more about N-channel, the operation of N-channel JFET.